Okay, so today we're going to work on simplifying algebraic expressions. I really like the use of algebra tiles, whether we are solving equations, whether we are representing expressions. I use these a lot because it gives us that visual representation of things that sometimes are a little bit harder to grasp. So this might not be a concept that you feel that you need the algebra tiles for, but just getting to know what they're like in this more simple context is important. So algebra tiles are hands-on math tools that help you visualize and solve algebra problems. They represent numbers and variables using colored tiles of different sizes. So you're going to see that we have yellow tiles and pink tiles. One's a positive number and one's a negative. So for example, if I was to have, I just want to change one of these pens. If I was to have like 2 of these orange tiles, then that would equal the number 2. If I had 5 of them, it would equal the number 5. I have rectangles, so I have x, and then I also have negative x's. So if I have an x tile, if I had 3 of these, that would represent, and I know my pictures aren't great, you can choose to go to this virtual manipulative website, polypad.amplify.com, and algebra tiles, and you can move them around. I'm just going to choose to draw them for this lesson. So if I've got these x's, that means 3x. And then we have things like these big rectangles. And the reason why they're x squared is I've got 2 side lengths together. And if I took x and I times it by x, it gives me x squared, because a number times itself is something squared. And if I, again, had 2 of those x squared tiles, it would be 2x squared. All right, so I want you to pause the video, and I want you to write down what this image represents with respect to tiles. So pause the video and write down what this shows. Okay, so hopefully you're coming back from writing those down. So if I'm thinking about this, okay, this piece is 3x. This 5 orange tiles is just a unit tile, so it's plus 5. Then I have these green x tiles, so I've got 1, 2, 3, 4, 5 of them, so plus 5x. These negative tiles, so I've got minus 4. And then I have minus, and you can choose to write the 1x in front, but you don't have to. But I have minus 1x tile. Okay, so this would be just the algebraic representation, and it's not simplified at this case. It's not simplified. So to simplify this, it means to put our like terms together. So for example, when I look at this, these x's, and even my negative x's, because they're all x's, are the same thing. So I'm going to put those tiles together. So I've got 3x plus 5x minus 1x. So that means that if I look at this x tile, it cancels out with one of these tiles, because one was a positive and one was a negative. And if you put a positive and a negative together, it makes a 0 term. So now what do I have left of my x's? I've got 1, 2, 3, 4, 5, 6, 7x left. And then I have to look and put together my other like terms. So when I look here, these x's and these are the same thing. So that's this 5 and the negative 4. So I'm going to write those down. Plus 5 minus 4. This step here is called collecting like terms. So what you're doing here is you're putting those like terms together. And then if I have plus 5 and minus 4, so if I'm looking at this, one of my negative ones cancels out with a positive one, makes a 0 term. This negative one cancels out with this one, so that's a 0 term. So I'm going to do that 4 times. And I'm left with a single 1. And if I think about what is 5 minus 4, that also gives me 1. Now, this answer that we have here is called simplified because it has only one of each term. Okay, so what I want you to do, we are going to do all of these examples. We're going to draw out the algebra tile representations, and then we're also going to do the algebra representations. You can choose to do the algebra tile representations on that website, and that way you can move the tiles around. Okay, so pause the video and try drawing this representation. Okay, so for this first one, if I was drawing my 3x tiles, I've got 1, 2, 3. I've got 5 positive tiles. 1, 2, 3, 4, 5. I've got 2x tiles. They're getting a little bit smaller. And then I've got 4 positive tiles. So if I was to write down my 3x plus 5 plus 2x plus 4, I can see in my diagram that my x's are the same. So those are my like terms. So if I put those together, 3x plus 2x, that gives me a total of 5 x's. And then in my diagram as well, I can see that I have these 5 tiles and these, and I drew too many, just noticing that now. Those 4 tiles, and if I were to move those tiles together, so I've got my 5 plus my 4, then I would have 9 tiles. So the answer, or my simplified version of this, is 5x plus 9. They're all positives, so nothing is canceling out. Let's try another one. I want you to pause the video, try drawing this out or representing it on the screen, and then also doing the algebra representation. Okay, so 4 x's. So I've got 1, 2, these were positive x's. I've got minus 2. I'm trying to remember those were pink. Minus 3x. And then positive 6. Okay, and now I'm going to write down my algebra question again. I've got 4 x's minus 2 minus 3x plus 6. So looking at what are my like terms in this case. In this case, 4x and negative 3x's are the same because they're the same type of tile. So I'm going to write them next to each other. If I were to put those tiles together, I would start to create 0 pairs because I've got a positive x and a negative x. So those cancel out to make 0. And that happens 3 times. So in this case, I'm left with 1x. And 4x minus 3x makes 1x when I take 4 minus 3. And then if I look, I've got my negative 2 and my positive 6. So I'm going to highlight those here. Negative 2 and positive 6. Negative 2, positive 6. And again, if I were to cross those out, I could make some 0 pairs. So this negative tile is going to cross out with this positive tile and make a 0 pair. And I'll see that I'm left with 4 positive tiles. So I'm going to write plus 4. And negative 2 plus 6 is 4. So my simplified expression is 1x plus 4. All right, pause the video, draw this out, and then we're going to come back when you finish drawing it out. Okay, so 2x squared, oh, that's a fat one. Fix the font there. So I've got 2x squareds. I've got 2x tiles. I've got 3 unit tiles. I've got 5 unit tiles. And I've got 3 more x tiles. Okay, so as I said, the algebra tiles are nice because they help us see what can go together and what cannot go together. One of our biggest mistakes in math when we're not sure what to do is that we think that this 2x squared goes together with this 2x. But I cannot put those things together because you can see in the diagrams that they're not like terms. This x squared and this x are 2 different shapes, so I cannot combine them to say that they are the same. So when I look at this picture, I've got my 2x squareds, and there's nothing that is like to them. So I'm just going to have 2x squareds. And then I continue through the question. I look for what else are other like terms. So here I have 2x's, and here I have 3x's. So I've got 2x and 3x, and I'm going to put those 2 things together. So I've got plus 2x plus 3x. And when I look at that, 2x squared plus 3x, that's going to give me a total of 5x. And then I have these 3 tiles and these 5 tiles. Those are like terms because they're the same shape. I've got my plus 3 plus 5, and plus 3 plus 5 gives me an answer of positive 8. So this is considered simplified because I've put all of my like terms together. X squared tiles are not the same as x's, and they're not the same as unit tiles. So I cannot put those things together. So this is simplified. Okay, one last question. So what happens when I have 2x squared minus x plus 4 minus x squared plus 3x minus 2? I want you to take a second, pause the video, represent this using algebra tiles, and then come back. Okay, so when I look at this representation, I've got my 2x squared tiles. I've got a -1 tile, so that was a pink one. I've got a plus, oh, no, sorry, minus x, not that one. Minus x plus 4. Okay, then I've got minus x squareds. So I'm going to do, there we go, plus 3x's. And then minus 2. And I'm labeling my diagrams, and that way I'm not mixing up my x squared boxes and my unit tiles, because right now I'm drawing them all kind of a little bit on the smaller side. It's better if you make them a little bit bigger, but I was running out of space. Okay, so now I'm going to start by collecting my like terms. So when I look at these pictures, I can see that I have the same shape here and here. So that means my 2x squared and my 3x squared are like terms. So I'm going to put those together first. Oh, now I'm noticing that I wrote this question down wrong. Give me a second. Minus x squared plus 3x and 2x squared and minus x squared are the same. So I'm going to write those beside each other. I've got 2x squared minus x squared. And if I think about what happens with those, very similarly to when I'm working with regular x tiles and unit tiles, a positive x squared makes a 0 term with an x squared, negative x squared, so now I'm left with 1x squared. Let's keep finding those like terms. I've got negative x, so there's one of those, and positive 3x. So I'm going to write those next to each other. Minus 1x plus 3x. Okay, let's simplify those. So this negative x makes a 0 term with this x. So I'm left with 2 x's. And then the final step, I've got this positive 4 and this negative 2. So I'm going to write positive 4 and minus 2 at the end. And a positive tile makes a 0 term with one negative tile. So I'm left with 2. Or if I took 4 minus 2, that would give me 2. So now this is simplified. Oh, sorry, there was one more example. Try this one. Pause the video, and then we'll take it up in a second. Okay, so if I was representing this with algebra tiles, I would start with 2 negative x squared tiles. I would have my 5x tiles, so these are a little bit longer. Negative 7. Minus 2 x's. Plus 3 unit tiles. And 4x squared tiles. So if I was to write this out, I have negative 2x squared plus 5x minus 7 minus 2x plus 3 plus 4x squared. So our first step is to collect our like terms. So here I've got negative x squared, or 2x squared, and positive 4x squared. So I'm going to write negative 2x squared plus 4x squared next to each other. And if I cancel out my 0 terms, negative 2 plus 4 gives me 2x squareds. Continue to find like terms. I've got my 5x's and my negative 2x's. So I've got plus 5x minus 2x. And if I cancel out my 0 terms, then I'm left with 3x. And my last set of like terms, I've got my minus 7 and my plus 3. And minus 7 plus 3, if I cancel out my 0 pairs, I'm left with 4 unit tiles, or negative 7 plus 3 is not positive 4, is negative 4. Okay, and there is your fully simplified answer.